So here we're going to look at switches used in different types of circuits. They're very self-explanatory, but I do want to go through a couple of pieces of dialogue for them. So in this little circuit here, we see SPDT and SPST. What does that stand for? It stands for SPDT, which is the first one on the top, is single pole double throw, and then the two other ones are single pole single throw. And so what does that mean? So the number of poles on a switch defines on how many separate circuits the switch can control. So a switch with one pole can influence one circuit. A four-pole switch can separately control four different circuits. A switch's throw count, on the other hand, defines how many positions each switch's poles can connect to. For example, if a switch has two throws each circuit, which is a pole, and the switch can be connected to one or two terminals. So for the top one, we have a single pole, so that's a single black dot, and a double throw, which means two open white dots. And that means two different positions that one black dot can connect to. And down below, we have a single pole, a single throw. So there's one black dot and one open dot. So that can either connect to that or not connect. So what this is used for is we can actually turn this circuit here using the switches into a variety of separate smaller circuits. And depending on what time it is, if you look at t equals 0, t equals 5, t equals 0, you can see what happens at what given time and what that circuit looks like. So we're going to do some more of this in lab, and we're going to look at this a little bit more in person. If you have any questions with this, feel free to ask in class or in office hours. But essentially what this is saying, it's a logic problem. It's saying at this time, what does the circuit look like? And you have to redraw the circuit for each one of those times. Because if there's a break in the circuit, essentially some of those circuit elements might be disconnected. And if they're disconnected, then we don't need to calculate them or use them in the circuit. So we're going to do a lot more of this. I'm going to have some practice problems with this as well. But I just want to get you accustomed to some of the switches and some of the stuff that you can do to that. Essentially, each switch makes kind of a different circuit from the initial circuit that you see there.